Good evening, children.
Good evening.
Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening.
Good
Good
evening.
evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Yeah, good evening. Good evening, children. Yeah, so last class, I had just written this one in short. For example, 3, we saw alternate ways of proving the results in example 3. I made the presentation. You can take a screenshot if you want. We already discussed the different ways of proving the results for example 3 in the last class. So last class, these alternate proofs we only discussed, and I just wrote it in short. So I have made it in detail for you. You can take a screenshot and, like alter the proof or whatever. We discussed this. The complete proof is now ready for you. All of you following that?
Yes, ma'am.
Yes.
All right, children. Yeah. Yes, tell me. Okay. Take a screenshot. So this is the next one. Yeah, we finished this one. We finished this. Oh, we finished this one also. We finished this. We finished this. Yeah, we have to continue from here. All right. So in question number 4, we are given that L and M are two parallel lines. So you can see here L and M are two parallel lines intersected by another pair of parallel lines. Intersected by another pair of parallel lines P and Q. P and Q. So L and M are two parallel lines intersected by another pair of parallel lines P and Q. So this is the figure. We need to show that triangle ABC is congruent to triangle CDA. So ABC, this triangle ABC is congruent to CDA, this triangle. So we need to show that this triangle is congruent to this triangle. That is, we'll have to show that these two triangles are identical. We don't have the triangles in our hand. You cannot, by doing it practically, meaning having the pictures of the triangle in your hand, you cannot place it one on the other and, say that they are congruent. All right. So this without, the actual pictures with you, from the information given, you'll have to show that they are congruent or identical. All right. So let's see how we have done the first one. So for both these methods, you need to first prove that this quadrilateral ABCD is a parallelogram. Okay, let's understand how to prove that ABCD is a parallelogram. See, what we have to actually prove is that this triangle is congruent to this triangle. That is what we have to prove. Now, to prove this, we'll first show that ABCD, this quadrilateral ABCD is a parallelogram. Now, in quadrilateral ABCD, I'm not saying in parallelogram ABCD, I'm saying in quadrilateral ABCD. In quadrilateral ABCD, AD is parallel to BC. Because L is parallel to M, it is not given that AD is parallel to BC. But we know that L is parallel to M. And what is AD? It's a part of L. And what is BC? It's a part of M. See here, what is AD? AD is a part of this line L. And BC is a part of this line M. Since L is parallel to M, AD will be parallel to BC. So AD is parallel to BC because L is parallel to M. Also, AB is parallel to CD. AB is parallel to CD or DC. AB is parallel to DC. Why? Because AB is a part of this line P and DC or CD is a part of this line Q. And since P is parallel to Q, it's given P and Q are parallel lines. Since P is parallel to Q, any part of P will be parallel to any part of Q. So AB is parallel to DC. AB is parallel to DC. So from these results, we have that in quadrilateral ABCD, both the pairs of opposite sides are parallel. Both the pairs of opposite sides are parallel. See here, one pair parallel, the other pair also parallel. So since both the pairs of opposite sides are parallel, ABCD is a parallelogram. ABCD is a parallelogram because AD is parallel to BC and AB is parallel to CD. So we proved that this is a parallelogram. Now that it is a parallelogram, you can use all the other properties of a parallelogram. They may not be given in the question for you, but you've proved it's a parallelogram. So you can use the other properties of or in fact, you can use all the properties of a parallelogram. So we know that in a parallelogram, opposite sides are equal. In a parallelogram, opposite sides are equal. Also, in a parallelogram, opposite angles are equal. In a parallelogram, opposite sides are equal and opposite angles are also equal. Both the pairs of opposite sides are equal. Both pairs of opposite angles are equal. So now let's look at this method one, this proof. So we prove that ABCD is a parallelogram. Now see here, we'll take up these two triangles, ABC and ACD. We'll take up the two triangles. AB is equal to CD. AB of the first triangle is equal to CD of the second triangle. Okay, why AB? See, I've always been stressing on this. All this information is about triangle ABC. All this information is about triangle ABC. The second information here is all about triangle ACD. So you must say that some side of this triangle is equal to some side of this triangle, or you must say that some angle of this triangle is equal to some angle of this triangle. So the information should be one part of this first triangle is equal to the corresponding part of the second triangle. So AB of this triangle is equal to CD of this triangle. Why AB is equal to CD? AB is equal to CD. Why? Because they are the opposite sides of parallelogram ABCD. Then BC is equal to AD. BC is equal to AD. Again, the same reason because they're the opposite sides of parallelogram ABCD. Opposite sides of parallelogram ABCD, so they are equal. And also AC is the common side. AC is the side common to both the triangles. See here, both the triangles have AC as a side. You can see here AC, AC. Both the triangles have AC as a side. So AC is the common side. So by SSS, because we have mentioned three pairs of equal sides. What have we mentioned? Three pairs of equal sides. So by SSS congruence criterion or congruence rule, the two triangles are congruent to each other. Now coming to the name. See, mostly what students do, we in the exam you don't have time, so you just write off this. You can just write this and say SSS rule. Because you'll have to show that this triangle is congruent to this triangle. So simply write that and say SSS rule. But now in the class, we need to understand the order, how to write that order. So take any two pairs of equalities. Take any two pairs of equalities. Now, if you take AB is equal to CD and BC is equal to AD, the first two, which we have written, the first two. Now, I told you what is common here, AB and BC. AB, BC. This is fine. AB, BC. So ABC is a triangle. So here it will be what is common here. D is common. So let us write AD as DA. CD, DA. Let us write AD as DA. It's the same. Side AD is the same as the side DA. So let's write AD as DA. So now see CD, DA. So triangle ABC is congruent to triangle CDA. ABC is congruent to CDA. But in the exam, you just don't mind. Just write this and write SSS rule. That's all. So what else? You can even take, I said you can take any two pairs of equality. So now supposing you take these two. So you have BC is equal to AD and AC is equal to AC. AC is equal to AC. Okay, now here C is common. Here C is common. So let's write BC, CA. BC, CA. Now here what's common? A is common. So DA, AC. DA, AC. So this triangle is BCA. BCA, BCA is congruent to triangle DAC. 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 Now you can see here. What is this? BCA. No, see here. BCA. A. That means in this order, second letter, third letter, and then the first letter, or the second vertex, third vertex, and then the first vertex. See here, B, C, A. So it should be D, A, C. See here, D, A, C. That's what we have here also. Am I clear, children? How to name the triangles in the correct order once they're congruent?
Yes, ma'am.
Okay. See
Yes,
here,
ma'am.
all right, children, very good. So here you can name it anyways. Here, now you'll ask me, here you've called ABC and ACD. Why suddenly you made it CD here? Anyways, this is fine. Here we are just mentioning the two triangles which we have taken up or which we have to prove are congruent to each other. So here the order is not important. Just name it however you want. Here the order, once you use this congruency symbol, when you use this congruency symbol, the name here and here must be meaning you should be able to relate this name to this one. Order becomes very important here when you use the congruent symbol. Yeah. If you want to write something, I'll just wait for 30 seconds. If you want to write something from the screen, you can write. Meaning what I have not for the screen, you can take, or you can take a screenshot. Or if you want to write something, if you want this one and this one, you can just make a note. I'll wait for some time. All right, children. So that's how we. Now, why was it important to prove that quadrilateral ABCD is a parallelogram? Because we've used the properties of the parallelogram here. Opposite sides of a parallelogram are equal. For that reason, you'll have to prove that this quadrilateral ABCD is a parallelogram. Only then you can use these, you can use this and this, meaning, sorry, this and this. AB is equal to CD and BC is equal to AD. Now let's see the second one. See the second one. So in the second one, you can see we've proved that the triangles are congruent using the ASA congruence criterion. ASA, that means two angles on the included side. Two angles on the included side. So see your children, I've numbered. And yeah, one more thing I've taken, see here, I've taken the triangle separately for you. I've shown triangle ABC here, triangle ABC here, and the other triangle ACD. See, this is triangle ABC. This is triangle ACD. See from here, ACD. ACD, this is ACD. This one is ACD. ACD. Okay. So you can see the triangle separately and the opposite sides equal. AB is equal to CD. Opposite sides BC is equal to AD. And this is the common side. AC is equal to AC is the common side. Okay. Next, again, I've taken up those two triangles. ABC, you can see here ABC and ADC as you find them here and here, as you find them here and here. So the two triangles, and I've also marked what I've written are equal. Okay. It's not important. You don't have to do this. You don't have to show. You can write it directly using this figure. But you'll have to number. If you're using numbers for angles, you'll have to number it in the figure. See here. This is enough. This figure is enough. In the figure which is actually given to you, draw that again and number in case you're not naming the angles using 3 letters. And if you're using numbers, number them like this. That you'll have to show. Because if you just say angle 1 is equal to angle 2 and it's not marked in the figure, then it becomes difficult for the teacher to evaluate. Yeah, this is enough. So this figure is enough. It's not important to draw all this. This just for the sake of clarity, I've shown that. But you don't have to draw them like this separately. If you're interested, you can do it, but not needed. You can use the main figure here. Okay, so you can see here, angle 1 is equal to angle 2 because alternate interior angles are equal. See here, parallel line, transversal, parallel line. Why parallel line? Because AB is parallel to CD. It's a parallelogram. Also, P is parallel to Q. So angle 1 is equal to angle 2. Alternate interior angles are equal. Angle 3 is equal to angle 4. Alternate interior angles are equal. AC is the common side. So it becomes two angles on the included side. See here, two angles. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. Okay, so you can see the parallel lines and the transversal I've mentioned here. All right. Now, for angle 1 and angle 3, see here, for angle 1 and angle 3, for angle 1 and angle 3 of this triangle, AC is the included side. Similarly, for angle 2 and angle 4, for angle 2 and angle 4, for angle 2 and angle 4 of the second triangle, again AC is the included side. You can see here angle 2, angle 4, AC is the included side. And that is what we have mentioned. AC is equal to AC. So by ASA, two angles, included side, two angles, included side. ASA congruence criterion, the two triangles are congruent to each other. Just write the same name and write ASA rule. Or if supposing you have to name it, then how do you do? Use the angles. Now angle 1 is equal to angle 2, right? Supposing you want to name it. So angle 1 is equal to angle 2. So if you write A in the first triangle, you must write C in the second triangle. Then angle 3 is equal to angle 4. Angle 3 is C. Angle 3 is C in the first triangle. Angle 4 is A in the second triangle. And then the remaining vertex, ACB. CAD, the third vertex, the remaining letter. The remaining letter, I'll tell you again. If you want to name the triangles, start with whatever is known to you. Because if you use some equality, use that. Because you can find its corresponding, part in the other triangle. So if you say angle 1, that is A in the first triangle, then it is equal to angle 2. So it is C in the second, vertex C in the second triangle. Then if you say angle 3, it's vertex C in the first triangle. And angle 3 is equal to angle 4. So it is vertex A in the second triangle. And then the third vertex. The third vertex is B in the first triangle. And the third vertex is D in the second triangle. So ACB congruent to CAD is also correct. See here, ACB. See here, ACB. So it will be CAD. AAA is not a valid congruence rule. AAA is not a valid congruence rule. Now, these are not the only two methods, children. Here there is a lot of information. You can also use AAS. You can also use AAS rule and show that the triangles are congruent to each other. Now, let me tell you why AAA is not a valid congruence rule. Class, use the emoji. Raise your hand. Rashmika, Shri, Madhumita, Tanishka, Arjun, Srijana, and Danya. Very good. Yeah. Yeah, children. Yeah. Why AAA is not a valid congruence rule? Now, see here. Now, this is an equilateral triangle. All right. This is an equilateral triangle. Let me call it ABC. Of side 5 centimeters. 5 centimeters. 5 centimeters. All right. So, what about the angles? 60 degrees, 60 degrees, 60 degrees. Here is another triangle PQR, PQR, PQR. 2 centimeters, 2 centimeters, 2 centimeters. Equilateral triangle, so 60 degrees, 60 degrees, 60 degrees. Equilateral, no? All sides are equal, all angles are equal. 60, 60, 60. And so both ABC and PQR are equilateral triangles. So you can see angle A is equal to angle P. Angle A is equal to angle P. Angle B is equal to angle Q. Angle C is equal to angle R. But you know that the triangles are not identical. The two triangles, when we say that they are congruent, that means they are identical. But you can see this PQR is smaller than ABC. Triangle PQR is smaller than triangle ABC. So you know that these two triangles are not identical. They are not congruent. One is small, the other is big. But see here, angle A is equal to angle P, angle B is equal to Q, C is equal to R. So that means if at all AAA is a valid congruence rule, if at all AAA is a valid congruence rule, then by AAA congruence criterion, these two triangles are congruent to each other. But are they congruent? Are they identical? Why is the silence for?
No, ma'am.
No, they are not identical. So that means they are not congruent. But if AAA is a valid congruence rule, then using this congruence rule, you will say that these two triangles are congruent, which is not true. So AAA is not a valid congruence rule. AAA is not a valid congruence rule. So you cannot use that. Supposing in two triangles, angles are equal. You cannot say that all the angles of one triangle are equal to the corresponding angles in the other triangle, so the two triangles are congruent is wrong. AAA is not a valid congruence rule. All right, children. Yeah, now I want the class to show that these two triangles, I want the class to show that these two, where is my cursor? That these two triangles are congruent using the AAS congruence criteria. Please use AAS and tell me, meaning and tell me the equalities you will be writing to show that these two triangles are congruent using the AAS rule. Yes, the time starts now and 1 minute for that. Yeah, children. Who's ready? Who is ready?
Ma'am, can I try?
Yes.
Ma'am, angle 1 is equal to angle 2.
Okay.
Angle 3 is equal to angle 4.
Angle 1 is equal to angle 2. Angle 3 is equal to angle 4.
BC is equal to AD because they are opposite sides of a parallelogram.
Perfect. BC is equal to AD. Correct. Very good. So this is AAS because it's two angles
And
and
not
some
the
other
included
side.
side.
Very good. Very good. Very good, Madhumita. Correct. Instead
Thank
of
you.
BC is equal to AD, what else you can replace BC is equal to AD with something else. What is that?
AB is equal to CD, ma'am.
Yeah, you can also write AB is equal to CD. You can
Yes.
also write AB is equal to CD. You can write 1 is equal to 2, 3 is equal to 4. And if you write AC is equal to AC, it becomes the included side. Instead of writing AC is equal to AC, if you write AB of the first triangle is equal to CD of the second triangle, or if you write BC of the first triangle is equal to AD of the second triangle, that will make it AAS, two angles and some other side. Very good. Very good. So what Madhumita said was angle 1 of the first triangle is equal to angle 2 of the second triangle. Angle 3 of the first triangle is equal to angle 4 of the second triangle. Alternate interior angles are equal. The included side is AC. Don't write AC. Then write AB. AB is equal to CD. AB of the first triangle is equal to CD of the second triangle. Opposite sides of a parallelogram are equal. Or instead of this, you can write BC of the first triangle is equal to AD of the second triangle. This also. So this makes AA. Any one you can write. Don't write everything. All that we know or all that is available. Just write three equalities which will satisfy some congruence rule. So this is AAS. Very good. Yeah. So, and it's something else. Some other way. AAS in a different way.
Ma'am, can I say?
Yes.
Ma'am, we can write angle QDL as angle 1.
Please, Srijana, please help me to mark it. No, which angle? I'll
Ma'am,
use
I'm
5
Arjun.
and 6. Angle?
Ma'am, we can write angle QDL, ma'am.
Where is QDL?
I'm in
Oh,
the top right.
darling. No, 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 no. This is not QDL. You're talking about this angle?
Yes, ma'am.
That's outside the figure, no?
Ma'am, that angle and angle ADC are vertically opposite angles, ma'am.
Okay, but okay, fine. Okay.
And angle QDL and angle um, DCM are corresponding angles, ma'am.
Okay.
And angle DCM, no, angle DCA
Okay.
and angle uh, ACB are corresponding angles, ma'am.
Okay. Okay, but okay. Oh, these are the two equalities, huh? Srijana?
I'm Arjun, ma'am.
No, but see, they are not the angles of the two triangles. See, what you write must be angles or sides of the two triangles. Now, you see, I think you said this angle is equal to this angle, but you have to talk about the three interior angles of this triangle and the three interior angles of this triangle. Which are the three angles of this triangle? Which are the three angles? Yeah, disable your mic, Srijana. See here, these are the three angles of triangle ABC. And these are the three angles of triangle ACD. Now you have to say some angle of this triangle is equal to some angle of this triangle. This is outside. This is outside the two triangles. No. Yeah, kindly somebody's mic is enabled. Please disable your mic. If you want to say something, you can say. Yeah. Some other way of saying AAS? Now you're all on vacations, right, children? All of you?
It hasn't started for me now.
Sorry?
My vacation starts on 2nd, ma'am.
2nd, huh? Oh.
Yes, ma'am.
What about the others?
For me too, from 2nd now.
Montfort?
It started now.
When is your school? When does your school reopen?
6th month.
6th. Okay. For Z school, from 2nd to 6th, is it? 5th. Or it's not
Yes,
announced?
2nd to 5th.
Okay. What about Srijana and Arjun?
1st to 6th.
1st to 6th. Okay. But tomorrow you have school. Okay. I'll let you know. Yeah, I want one more AAS. Or shall I say? Okay.
Angle D and angle B can be
Yeah.
opposite angles of a parallelogram.
Parallelogram are equal. Very good. So angle B is equal to angle D. Angle B, see, angle B is of this triangle. Angle D is of this triangle. So you can mark them 5 and 6 if you want. So you can call this one 5, you can call this 6. And angle 5 of the first triangle is equal to angle 6 of the second triangle, because reason is, as she said, opposite angles of a parallelogram are equal. So 5 is equal to 6.
And then A is equal to C, ma'am.
Okay, this angle 1 is equal to 2, is it?
No, ma'am, the whole angle, the full angle.
A whole angle you cannot take, because the whole angle is not a part of any, meaning angle A is in both the triangles, the whole of angle A.
Yes, ma'am, I get it.
And the whole of angle C is in both the triangles. A part of it is in one triangle, a part of it is in the other triangle. So we cannot use that. We can use this because this one fully is in this triangle and this one fully is in this triangle. This you cannot use. Of course, angle A is equal to angle C, but that information we cannot use because this is not completely in any triangle. So ASA can be like this also, children. You can say angle 5 is equal to angle 6. Angle 5 is equal to angle 6. And then you can say BC is equal to AD. BC is equal to AD because opposite sides of a parallelogram are equal. And then you can say angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Alternate interior angles. So see 5, 3 BC. 5, 3 BC. 6, 4 AD. 6, 4 AD. So many ways. You can do ASA, AAS, SSS. So I've told you SSS here. SSS is only this one. There's no other way of getting SSS because we've used all the 3 pairs of equal sides. So you don't have anything extra. SSS is only this way. But you can, for AAS and ASA, you can write the equalities in different combinations. Different ways you can write. Yeah, you can just make a note of this like this. You can just number this 5 and number the 6. And you can just make a note of this. You can also write angle 5 is equal to angle 6. BC is equal to AD and angle 3 is equal to angle 4. So like this you can keep, because there's a lot of information, a lot of equalities. Done, children?
Yes, ma'am.
Yeah. Yes. So here, no, see here, see children, if it is, you need to, the recordings are available. It's the same playlist link. There's only one link for one chapter. I've mentioned this earlier. There's only one link for one chapter. That is, there is only one playlist link for one chapter. So I've already shared the the playlist link with you. So at the end of every class, the videos will go into, the recordings will go into the same link. So save that link that playlist link, and you will find all the videos in the same link. You don't have to, if you miss one class, you don't have to ask me for the link. It's that link only, one link for one chapter. So you already have the link. You tap on that, you will find all the recordings. All recordings will be updated in the same link. So till we finish congruent triangles, all the recordings will be in that only. So you don't have to request me for the recordings. Please watch the recordings. If you feel something is not clear, you need to watch the recordings. I've been telling you that you'll have to use one angle or one side of the first triangle. See, there is nothing like this is the first triangle, this is the second triangle. There are two triangles. For you, anything can be the first, other is the second triangle. Okay. So an angle or a side of the first triangle is equal to angle or side of the second triangle. This is a valid equality. Writing an angle or a side which is not a part of the triangle is meaningless when it comes to congruency. All right. Krishmika, you finished your exams, all your exams?
Yes, ma'am.
When did you finish?
28th, ma'am.
Today. Oh no, yesterday.
Yesterday, ma'am.
Okay. Yeah, children. So line L is the bisector of an angle A. So there is an angle. So there's basically only one angle here. This figure is only one angle. Okay, that angle is A. Line L is the bisector of an angle A. This is angle A, and this is that line L. This is that line L. Okay, line L is the bisector of angle A. How do you draw an angle? How do you draw an angle like this, right? So this is angle A. This one is angle A. And this line L, you know, is the bisector, of this angle. That means this portion is equal to this portion. If the whole thing is 50 degrees, this will be 25 degrees, this will be 25 degrees. Because L is bisecting or bisects this angle. So line L is the bisector of an angle A. And B is any point on L. B is any point on L. B is any point on L. See here, B, this is the line L. This is the line L, and B is any point on the line L. BP and BQ are perpendiculars from B to the arms of angle A. So see, this is one arm of angle A. This is the other arm of angle A. Okay, this is a point on the line L. BP and BQ are perpendiculars. You can see it here, are perpendiculars from B to the arms of angle A. So you can see how nicely, you know, this figure is described. You know, you describe something when it comes to your English subject. It's so well described, this figure. So even this figure can be described, seen like this. So what is it? How is it described? Line L is the bisector of angle A. So this is angle A. This is angle A. Okay. Line L is the bisector of angle A. Then B is any point on the bisector L. B is any point on the line L or the bisector L. BQ and BP are perpendiculars. BP and BQ are perpendiculars from B to the arms of angle A. To the arms. How many arms an angle has? Two arms. BP and BQ are perpendiculars. That is, they make 90 degrees with the arms of the angle A. Given this, you need to show that these two triangles are congruent to each other. See, these two triangles are congruent to each other. And also you'll have to show that BP is equal to BQ. BP is equal to BQ. These two things. Show that these two triangles are congruent to each other. And then also show that BP is equal to BQ. Now I have numbered these angles 3, 4, and this portion as 1 and this portion as 2. You can see it here. You can see it here. Okay. So that's why you need to draw the figure again. If you're numbering it, you need to draw the figure again and mark the angles like this. So you always start. So till here is the question. Till here is a question. The figure is given to you. And till here is a question. Show that. So how do you start the proof? Given, to prove, and then proof. There is no construction here. If there's a construction, you'll have to write construction. Whatever is a construction, you need to write that. Otherwise, this is the order. First given, then to prove or to prove that, and then the proof. So given, what is given? L bisects angle A. That means angle 1 is equal to angle 2. Okay. And then it's given that BP is perpendicular to AC. Oh, AC, I have not marked C. Okay, this is AC, children. 1 minute. I have not marked. Whatever marked C and D. All right. BP is so I need to mark C here. I need to mark D here. Fine, I'll do it. To mark C here and D here. All right, children. So I've written BP is perpendicular to AC. So you can see here BP is perpendicular to AC and BQ is perpendicular to AD. BQ is perpendicular to AD. That means BPA is 90 degrees and BQA is 90 degrees. So this is what is given. This is what is given. All this is given to you. We need to prove these two things. Write the same thing here to prove whatever is given here to prove. Now the proof. Draw the figure, number the angles. It's more convenient, when you number it like this, number the angles and write the names of the two triangles, which you have to prove are congruent to each other. Now see here, angle 1 is equal to angle 2 given. Because here given means this one, this given I'm saying. Only if you write this given, you can give this reason given. See, this given is not given in the question. We have written it. In the answer under given, we have written it. That's the meaning. Given meaning, I have listed it here. L bisects angle A, that is angle 1 is equal to angle 2. Given, this given. Angle 4 is equal to angle 3. Angle 4, this angle 4 is equal to angle 3. Given. Because see, we've mentioned 90 degrees, equal to 90 degrees. Each equal to 90 degrees. Then AB is equal to AB common side. AB is equal to AB common side. So the two triangles are congruent. You know how to name it now. So the two triangles are congruent. And once they're congruent, their corresponding sides are equal. So BP is equal to BQ. BP is equal to BQ. See here, PB, QB, PB, QB, or BP and BQ. What's the name? How do you name the triangle? If you say APB, APB, A goes with A only in the other triangle. If you say A, P and B, P is Q here. So AQB, AQB, APB, AQB, APB, AQB. So you can see here, PB is equal to QB, PB, PB is equal to QB. That's what we had to prove. PB is equal to QB, this one. Yeah, go through the proof. If you have any question, you can ask me. I had already asked you to write down all this in your notebook. If you have not written, you'll have to complete it today. So I have to mark. See, please mark this in your book. If you've already done this proof, please mark this in your book, C and D. Yeah. Done, children? Any questions?
No doubts, ma'am.
No doubt.
No doubt, ma'am.
All right. Srijana?
And 1 minute, can you show the slide note?
Yeah, sure, sure.
Completed.
Yeah. Yes, I want Srijana to give me the proof for this one. Srijana, name the two triangles. Yes, quickly. In triangle. Arjun.
Ma'am, can you hear me, ma'am?
Yes, Srijana. In triangle. It's the same proof. It's the same proof which we just understood.
Ma'am, in triangle APB is congruent to triangle AQB. Ma'am,
In triangle.
triangle APB and triangle AQB.
AQB. 1 minute, 1 minute. I just want to make some more changes. Just 1 minute. Yes, Srijana, tell me. Yes, Srijana, please go ahead.
Angle APB equals angle AQB.
Now tell me, use the numbers I've marked.
Ma'am, I'm Arjun, ma'am.
Use the numbers. I've marked the angles. No, use the numbers.
Yes, ma'am. Ma'am,
Yeah. Arjun. Tanishka.
Yes, ma'am.
Yeah. Tell me.
Angle 1 is equal to angle 2, ma'am. Oh,
Okay.
and angle 4 is equal to angle 3. These are given, ma'am.
Okay, then.
Angle AB and angle AB is common in the both triangles.
Krishmika. Krishmika. Yeah, all of you mute yourself. Krishmika, unmute. Yeah, Krishmika. Now tell me, is this correct? Is Tanishka right?
Yes, ma'am.
Tanishka is right, is it?
Yes, ma'am.
Okay, fine. What about Madhumita and Danya? Tell me.
Ma'am, no, ma'am, she's not right. It's wrong, ma'am.
What
It's
about
wrong.
Danya? Danya, what do you say?
It's wrong, ma'am.
No, children, see, the problem is, I've been telling you that the first information should be of the first triangle. Then after the equal to sign, what you write should be of the second triangle. All of you are wrong. Tanishka is wrong. Arjun and Srijana, they did not answer at all. Pushmita is wrong. Tanishka is wrong. Take it seriously. See, we've just started the chapter. Now you can still go through the recordings. But I'll tell you something. It's all given in the question. We just have to write in a specific way. What is that method? Name the two triangles. Then on the left side of the equal to sign, we are writing the parts of the first triangle. It can be an angle or side. Then after the equal to sign, we are writing the corresponding angle or side of the second triangle. And it's all given to you. You just have to write these three equalities that will satisfy some congruence rule. Everything is given in the question. So you're not following that, format. Very simple one. All of you go through the recording. See from the beginning. Make sure by the next class you understand what I'm telling you. Now, none of you are following. All these four you're not following. It's very clear. All that I can suggest is go through the recordings. That's the benefit. Even if it was physical class, you will not have the recording. Gone is gone. Now you have the recordings with you. Watch the recordings and prepare yourself well to answer correctly in the next class. Don't be disappointed. It's very simple. Your focus is, you should only ask yourself what is missing in you. You're not focusing, or you have some doubt, you're not getting them clarified. Ask yourself, why when my friends are able to understand, why I am not able to understand? Ask yourself that question. We are not here to waste your time. So please find out why when a few of my friends are able to understand, why I am not following. Yes, Danya, tell me what's the correct proof?
Ma'am, it's actually angle 1 is equal to angle 4, ma'am.
Then?
And angle 2 is equal to angle 3. And AB is equal to AB, which is common.
Correct. Angle 1 is see here, angle 1 is equal to 2. 1 is of this triangle, 2 is also of this triangle. That is the first mistake. You are saying two angles of the same triangle are equal. That's the first mistake. And angle 1 is equal to angle 2. This is a right angle. How can angle 1 be equal to angle 2? Angle 1 is equal to angle 2. How angle 1 is equal to angle 2? Angle 2 is a right angle. Angle 1 is acute. They are both the angles of the same triangle. Then angle 4 is equal to angle 3. Angle 4 is equal to angle 3. Angle 4 and angle 3, who said they are equal? 3 is 90 degrees. 4 is an acute angle. And they're angles of the same triangle. What is the use? Okay, even if they're equal, what's the use? You're writing an equality of two angles of the same triangle. So today, in this meeting of 6 children, 4 of you have not understood the basic, the nature of the proof. The way the proof is, written, the basic nature is not clear to you.
Ma'am,
I think this is the third class. Please watch the 2 recordings, including today it will be 3 recordings. Please watch and, attend the next class with clarity.
ma'am, for this question, I'm getting the answer by ASA congruency rule, ma'am.
Srijana, you were already given the chance and you did not answer it correctly. I'll ask you again in the next class.
Ma'am, I'm not Srijana, ma'am, Arjun, ma'am.
Arjun, yes, Arjun.
Ma'am, I got the answer as ASA congruency rule, ma'am.
But why you didn't answer when I asked you?
Ma'am, there was a network issue for me, ma'am.
Come on, yaar, what is this? No network issue. Everything is fine. Okay, tell me. Let me mark the angles now. Tell me. Yeah. In triangle. In triangle.
In triangle APB.
Yeah.
And in triangle AQB.
Okay.
We have angle APB and angle AQB equals
Use
90
the numbers.
degrees.
Use the numbers. Use the numbers.
Ma'am, angle 4 and angle 2, ma'am. That's equal to 90 degree, ma'am.
Then
Angle 3 and angle 4. Angle 3 is equal to angle 4. No, ma'am. Angle 3 is equal to angle 1.
why 3 is equal to 1?
Because AB is the bisector of angle A.
Okay, correct. And then the third thing.
And then AB is equal to AB.
So what's the rule?
Ma'am, ASA rule, ma'am.
Okay. For angle
Angle side angle, ma'am.
for angle 4, okay. In triangle APB, we have mentioned about angle 4 and angle 3, right?
Yes, ma'am.
Which is the side included by angle 4 and angle 3?
Angle
Angle 3 and angle 4 include which side?
AP is done.
AP. And angle 1 and angle 2 include which side? Angle 1 and 2.
AQ, ma'am.
AQ. But what have we written here?
AB is equal to AB.
So is it ASA or AAS?
AAS, ma'am.
It's 2 angles and some other side. It's not the included side.
Yes, ma'am.
Yeah, very good. Very good, Arjun. Yeah, good. By AAS rule, the 2 triangles are congruent. Yeah. Go through and one of you will explain this. You've already written this in your notebook. I want one of you to explain this. Yeah. Okay, who wants to explain this? Nobody?
Ma'am, I'll try.
Okay, Madhumita, go ahead.
So it's given to us that angle 1 is equal to angle 2, ma'am. And
Okay.
then, but to make angle, to complete it, and the triangle we've taken is triangle ABD, I mean ABC and triangle DAE, ma'am.
Why should you take up these two triangles? Why not some other two triangles?
Ma'am, because only these two triangles include all the information which is given to us.
Correct. Yeah. So you'll have to pick two triangles. See, we are given some information. That information can be applied to some two triangles. So you'll have to select the triangles accordingly. And also, you must take a triangle which has BC as a side, another triangle which has DE as a side. Because only then, when you show that those two triangles are congruent, you will find the sides BC and DE, and you can show that they're equal. How do you show that these two sides are equal? You must prove that some two triangles are congruent to each other. When the triangles are congruent, their corresponding sides are equal. So here the triangles are not mentioned. Some information is given to us. We don't know which two triangles we have to take and show are congruent to one another. We don't know. But we have to show that BC is equal to DE. So you must take up one triangle which has BC as a side and another triangle which has DE as a side. Take up a triangle which has BC as a side, another triangle which has DE as a side. So we have taken up triangle ABC, which has BC as a side, BC. And we have taken triangle ADE, which has DE as a side. ABC, ADE.
Yes, ma'am. So in triangle ABC, to complete the angle A is divided by a line AD, ma'am. To complete
AC.
it, yes, ma'am, it's divided. So to complete it, we have to add both the angles. So we are adding angle 3 to both the triangles,
Hmm.
and then the angle becomes complete. So angle BAC is equal to angle DAE, ma'am.
Okay.
And now taking triangle ABC and DAE, it's given to us that AC is equal to AE and angle BAC is equal to DAE. We proved that previously. And AB is equal to DE. That information is also given, ma'am.
AB is equal to
AD.
AD.
So using side congruence criterion, we can prove that triangle BAC is congruent to triangle DAE, and by corresponding parts of congruent triangles, BC is equal to DE, ma'am.
Very good. Correct. Very good. All right, children. So I'll just repeat what Madhumita said. So this is the triangle ABC. We take up this triangle ABC and this triangle ADE, this triangle ADE. So reasons why we take up these two triangles. See, you cannot take up this small triangle. Now think, see, you cannot take up this small triangle and one big triangle here and show that they are congruent. How can you show that they are congruent? You know they are not congruent. One is small, the other is big. So we take up triangles ABC and ADE. One is because here AC is equal to AE is given to us. AC is equal to AE is given to us. We need to take two triangles wherein we can use these equalities that are given. And also the triangles must have these two sides. That is, one triangle must have BC as a side. Another triangle must have DE as a side. So ABC and ADE are the two triangles which we have taken up. And look at this here. See here, this is ABC. This is ABC. This is ABC. I've shown that separately here, ABC. And this is ADE. This is ADE. That's what I've shown separately here. ADE. See here, this is ADE. Okay, we have taken up these two triangles and mark of what is given. ABC and AD, what's given? AC is equal to AE. See, I've marked here double lines. AC is equal to AE, double lines. Then AB is equal to AD. See, the single line. AB is equal to AD. Then BAD is equal to EAC. BAD you cannot mark here. BAD you cannot mark here. And then EAC, EAD we don't have EAC. So you cannot mark this one because BAD is only this part. BAD is only this part. And EAC is only this part. EAC, this one. Now there is this portion which is missing, meaning which is this portion which I have marked as angle 3. This angle 1 and angle 3 together makes this angle. See here, angle 1 and angle 3 together makes BAC. BAC. In triangle ABC, in this triangle ABC, we have angle A. Angle A is this full angle, which is angle 1 and 3 put together. This angle A is angle 1 and 3 put together. And I have marked this as angle 1 and this one as angle 2. BAD as angle 1, BAD as angle 1. And I've marked EAC, EAC as angle 2. See, this is EAC, EAC as angle 2. Now, this angle is angle 1 and 3 together. See here, this angle BAC, BAC, you can see from this figure that angle 1 and angle 3 put together, 1 and 3 together is BAC. Similarly, 2 and 3 together, 2 and 3 together, 2 and 3 together is DAE, DAE. So if you prove that this angle is equal to this angle, then you can see clearly it is SAS, S side, angle, side. Two sides and the included angle. Two sides and the included angle. See, for this angle, these are the included sides. Sorry, for this angle, these are the arms. For this angle, these are the arms. For this angle, these are the arms. So if you can show that this angle is equal to this angle, then easily by SAS congruence criterion, the two triangles will be congruent to each other. So this is angle 1 equal to angle 2. This is angle 1 equal to angle 2. So write that this given angle 1 is equal to angle 2 given here. BAD EAC. Angle 1 is here. BAD, you can see here. BAD is this one. EAC is this one. Angle 1 is equal to angle 2 given. Add angle 3 to both the sides. Add angle 3 to both the sides. So angle 1 plus angle 3 is, that is, add 3 to the left hand side, add 3 to the right hand side. Angle 1 plus 3 is equal to angle 2 plus 3. Now what is angle 1 and 3 together? BAC. What is angle 2 and 3 together? 2 and 3 together? DAE.
Angle DAE.
DAE. You can see it here also. 2 and 3 together is DAE. A and 3, sorry, 1 and 3 together is BAC. So now take up these two triangles. Mention the equalities you have. This is the included angle. So by SAS rule, the two triangles are congruent to each other. And once you show that they are congruent, the two triangles are congruent, their corresponding sides are equal. So you can see here BC is equal to DE, CPCT. We have to show that BC is equal to DE. BC is equal to DE. So BC is equal to DE, CPCT. BC is equal to DE, CPCT. You can see here the first and third letter, the first and third vertex. Shall we go to the next one?
Yes, ma'am.
Yeah.
Yes, ma'am.
All right. So this is a similar one. Yeah, I want Tanishka or Krishmika to explain this. Tanishka or Krishmika, whoever, like volunteers first.
Can I, ma'am?
Yes, Tanishka, go through. Just take some time, prepare yourself, and then you can say.
Yes.
Who was that? Tanishka or Krishmika?
Tanishka, ma'am.
Yeah. Okay. Just take some time. You can go through the answer on the slide and then try. Just come back. Just a minute. Yes, Tanishka.
Yes, ma'am. AB is a line segment, ma'am, and there is a midpoint at AP. So AP is equal to BP, ma'am, and
Okay.
BAD, ma'am. BAD is angle 1 and ABE is angle 2, ma'am.
Okay.
So angle 1 is equal to angle 2, ma'am.
How do you
And
know that?
it
How
is
do you know that
given, ma'am.
angle? It's given. Correct. It's given. This is angle 1. This is angle 2. They are equal. Correct.
And
Okay.
angle EPA is equal to DPB, which is nothing but angle 3 is equal to angle 4, ma'am. It is also given, ma'am.
Okay. Fine. Okay. Okay.
And here we have to prove uh, triangle DAP is congruent to EPB, ma'am. And
Okay.
we have to also show AD is equal to BE, ma'am.
Okay.
Angle APD is nothing but 3 plus 5, ma'am, because it is APD is bisected by uh, EP, ma'am.
Okay. No, there is a line segment PE through the angle. It's not bisected. Bisected means it's divided into two equal angles. You're right. There is a line segment PE. There's a line segment PE going through this angle. Going through this angle. That's not a bisector because it's not given. It's bisected. Okay, you're right. Now this triangle DAP. See, this is triangle DAP. Okay, this is triangle DAP. See here. This is triangle DAP. DAP. When you see this triangle DAP, this angle is 3 and 5 together. That's why I've written 3 and 5 here. And when you take the other triangle, I know that's what you want to say. When you take the other triangle, that is EBP. When you take the other triangle EBP, this triangle, you can see that this is the complete angle. This is the complete angle. That is 4 and 5 together make this angle. Angle EPB is 4 and 5 together. Yeah, we won't say that PD bisects this angle. We won't say that. There is a line segment PD going through this angle. That's all. Yes, sir. Please continue, Tanishka. You're right so far. Except that we cannot use
Yes,
the word bisects.
yes, ma'am. Angle APD is equal to angle 3 plus angle 5, and angle BPE is equal to angle 4 plus angle 5. So angle APD is equal to angle BPE. It's proven, ma'am.
So that means you should write this information. Angle 3 is equal to angle 4. Angle 3 is equal to angle 4. And you must add 5 to both the sides. You must add 5 to both the sides. So angle 3 plus angle 5 will be equal to angle 4 plus angle 5. So what is 3 plus 5? What is angle 3 and 5 together? APD. APD. See here, APD. And what is 4 and 5 together? 4 and 5 together is EPB or BPE. So we call that result A. Now continue in the two triangles.
In a triangle APD and BPE, angle 1 is equal to angle 2. It is given, ma'am. And angle AP is equal to angle BP. It is also given, ma'am.
That's not
And
angle.
now we have
Side AP is equal to side BP. Side, not angle. Side AP.
angle APD and angle BP is equal. It is now proven, ma'am. And triangle ADAP is congruent to EBP by side angle congruency, ma'am. And so we have proven that two triangles are congruent by ASA. So AD is equal to BE by CPCT, ma'am.
Very good. Very good, Tanishka.
Yes, ma'am.
Yeah. Now, clearly, children, for angle 1 and that is for this angle and this angle, AP is included side. And for this angle and this angle, BP is included side. So we have mentioned about this angle and this included side. This angle, and this included side. So clearly it is two angles in the included side. ASA rule. Correct? Okay, so Tanishka, I think you were only stuck with the earlier one which I asked, or maybe now it's clear to you. But anyways, I request you to watch the recordings, the earlier recordings, and be more clear before you join the next class. All right?
Yes, ma'am.
Yeah. All right, children. So that's it for today's session. Next class, I might start off with Heron's formula also. So don't miss. Yeah, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.